Okay, so we're now ready to install the prop adapters onto the T-motors. And in the kit with each motor, you're given the parts required to do that. We're going to need our thread lock again and our cloth. And these take the 1.5 millimeter Allen driver. So to begin, we're going to take the prop adapter and we're going to sit it on top to align the 3 holes. Now we're going to insert one of the cap heads and we're going to just engage the threading. Don't tighten it all the way. And we're going to do the same for the second one. And for the third. Again, just to repeat, we are needing to apply even pressure throughout. Don't just tighten down one of them because you may get it sort of on an angle. So once you feel resistance, you move to the other one. And then over to the last one. Now back to the first. And check them all with the same amount of pressure. And now we're going to increase the pressure and go through them again. Increase again, increase again, and increase. And this way it's going to be aligned just perfectly. And there won't be any warping of the part, or it's not going to be crooked, and that's very important. So I first tighten them in. Now we're going to loosen and remove one to apply the thread lock. Now I've already gone ahead and I've used the alcohol to clean all the threading. Remember, anytime you use thread lock, we're going to need to do that. So holding on to the bolt, we're going to apply the thread lock at the end again and use your finger and roll it around. And you should see an even distribution of the blue. And it shouldn't be quite a gob of it, but it's through the threads. Now, holding it, we want to tighten it in, remove it. Tighten it in a little more, remove it. Tighten it in more, and then that way you work the thread lock throughout the threads. And then we tighten down. Remove the second one, and we do the same. So we do that process for all the bolts here, and we'll do it again for the rest of the motors. Now while I'm doing this, I just noticed another tip that I can be teaching you, which is I always leave the motors on its side after I've thread locked, just in case if you've got too much thread lock, it doesn't run down into the coils and it just sits on the side. And that's been working for me. Not that I put too much, but just in case, right? So it's a precaution. So I've done 2 of the motors and I'm working on the third one, and I've got 1 more left. And to be honest, thread locking is my least favorite part of the build. Doing the prop adapters are the least favorite part of the build. It gets so repetitive and not very fun. And sometimes if you get distracted, you've forgotten which ones you've thread locked, and you remove one that you've already done, and that's no fun. So it's like it takes a lot of concentration and it doesn't seem like you're doing much. And yep, my least favorite. It's funny to think what everyone's least favorite part of the build is. Yeah, so if you've got one, put it down in the comments. Your least favorite part of a Miniquad build, what is it? For me, thread locking these goddamn prop adapters. Alright, okay, we've done that. We've attached all the prop adapters and thread locked them to the motors. And before we can celebrate, actually, we've got another thread locking thing to do, which is these are 4 of the M3 6mm, and they're going to be used to attach the motors onto the arms. Okay, now in this formation, I'm going to be doing that one first, second, third, and fourth. Back to first, second, third, and fourth. And each time that you make a round, you increase the amount of pressure. And I know I've been repeating this over and over again, but it's very important. It really is. Okay, so there we go. Now, similarly again to the prop adapter, we're going to be removing one, applying thread lock, tightening it back in, removing the second one, thread lock, tightening it back in, and so on until we're done all 4. So I'm going to go ahead and I'm going to install all 4 motors onto the arms. Okay. So all the motors have now been attached to the motor arms, and next we're going to be installing the ESCs. So 4 of them sit on this bottom plate, and the motor wires go through the channel and will get soldered to each ESC. This is the power distribution board that's provided with the kit. It's double-sided, which makes it unusual. If the positive wire on the LiPo is touching this pad on the B, every pad that's marked B will be positive. And if the negative wire on the LiPo touches one of the pads on the A side, then all the A's become negative. So that's how it works. And it's designed for you to solder onto the pads, all the ESCs, and it's going to be sort of held in a cluster. And afterwards, you want to run a liquid electrician tape or use a electrician tape to insulate the pads and the wires so that it doesn't touch the carbon fiber and short, because it's double-sided and it sort of just sits inside that space. And that works. I do it a little bit differently, where I'll show you. I like to have this PDB permanently mounted onto the bottom plate, but it's sitting above so it's not touching the carbon fiber, and it gives plenty of space for the pads and wires clearance so that it's not going to touch. And to do that, we're going to need one of the M3 6mm that's provided in the kit, nylon standoff, usually meant for installing flight controllers, and I believe this is 6mm height, and a nylon M3 nut, also used with one of these. So we're going to mark where that PDB is going to go, and we'll mark the center point like that. We're going to be drilling with 1/8 inch drill bit, and to start a pilot, I find it convenient to use a hobby knife. And we're going to start the pilot hole so that the drill bit's not going to slip when we drill into the carbon fiber. Okay, it's ready for the drill. Okay, so the hole is finished. So we're going to use the 6mm M3, and we're going to put it through the bottom. Then we're going to take our nylon standoff, and we're going to screw that on. You can use a 5.5mm socket and get that tightened in. Because it's nylon, don't crank it too hard. You are going to strip it, so just enough to keep it on there. Like that. Then just choose a side. Let's start with the A side. And we're going to take our nylon M3 nut. Again, you can use the 5.5mm socket. And we're going to tighten that down. And until now, the board is symmetrical. The plate is symmetrical. It doesn't matter what's the front or back, but let's designate that now. So when we look at the Miniquad from a top view, this is the front, let's say. Then this is motor 4, motor 3, motor 2, and motor 1. These two, which is motor 4 and 1, are going to spin in a clockwise direction. And motor 3 and motor 2 are going to spin in a counterclockwise direction. So let's mark that just for our reference and ease while we work. And I'm going to take some tape again, and we're going to make little flaps. So we'll start over here. Okay, and using a Sharpie, we are going to mark the numbers. So this is 4, and it's going clockwise. Another useful thing with these flags is that when we do a motor test in clean flight or base flight, you can see them spinning a lot easier, because of course we don't want to be testing that with propellers on. So these are kind of like a safe propeller, just to see direction. So this one is number 2, and this is counter clockwise. Motor 1, clockwise. And lastly, number 3, counterclockwise. So I've cut a piece of craft foam, 9mm by 18mm, and it's going to be stuck on the end of the ESC here. That way it'll protect it if it makes contact with the PDB. Okay, so when we look at this positive wire, it can either go over here or it's going to go over here. So using some wire snips, we remove the extra wire. It can either go to this one or this one. Let's go down to this one here. Okay, so let's prepare these for soldering. So the first ESC has been soldered onto the PDB, and I'm going to be doing the second one here. So just place it on top where it's supposed to go and line up the wire. If it's lifting up, it helps to actually pre-bend the wire to exactly where you want it. Okay, so those two are done. Now we're going to do the same for the other two. So the same thing, we place them down on the spots that we're going to install them. Okay. And then, well, let's do the first one. And then we'll figure out where the wire is going to go. I think this is better than going over here. It's going to be, I think, too short of a wire. So we'll go over to this side. Okay. Then the last ESC will come over to here. Okay, so let's tin the ends and we'll solder them onto the PDB. All 4 ESCs have now been soldered onto the PDB, the positive wires. And I've got the USB fan here running. It's just cooling everything down. In between solders, I like to cool it down, especially if you've got short wires or if you spend a long time on a particular pad. Of course, the heat travels and it can blow circuitry, so be careful. This is the positive LiPo lead that's been included with the kit. I have it exiting from the side of the EPIC. I personally like to have it from the right side. That's motor 2 and motor 1. This is a 22 gauge wire. It's also being soldered to the PDB. This will provide power to the VTX, LEDs, anything that needs secondary power. This is going to be a 4S setup, and a lot of the VTXs can take higher than 12 volts, but I always like to step down, so I'm going to be personally soldering a Pualu onto this. So that's that. We can turn off the fan now. So we're now ready to remove the PDB from the nylon standoff that we've added. And you can see the beauty in doing it this way. It's a lot more organized. So it stays together in one cluster. And right now we still have a lot of wires, so it's a bit messy, but it's going to clean up after this next step. So you're going to seat it back upside down. And we're going to attach the nylon nut again to keep everything in place. Okay, so now it's there. We're going to do the same as we did on the positive side. Okay, so I've got all the negative wires soldered onto the PDB, including the one for the LiPo and the one for the secondary power. And I've removed it again and I flipped it and it's back to its original orientation. And the nylon nut has been tightened on using the 5.5 socket. So the next thing we need to do is we need to attach the ESCs onto the plate. And if you look at the shape of the ESC, it's making contact over here, but it's sort of lifting up on this end. So what we're going to do is we're going to use 3M double-sided tape and we're going to apply it onto the bottom of each of these ESCs. You don't want the double-sided tape to only make contact like on one little point and the rest of it just hang, because that's pointless. But if you used 2 layers, on the middle area here, it works out pretty well. So to do that, we're going to take the tape and we're going to bend and fold over to make the double layer. Then we're going to cut, remove the backing, stick it to the middle area right here. It's like a recessed little space. And situate it exactly where you want it. And push down. And when you look at that, it's seated perfectly on that pad. And that's good. So you want to do the same for each of these. So you want to get each of the ESC signal wires routed in a way that it clears any obstacle, and it's going to come out through the middle because the top plate has that hole, and remember we used the file to smooth it out so it's not going to cut any of the wires. Also through that hole is going to be your secondary power, so that's also going to go through that hole. Now as you can see, once we've attached the top plate, you won't know which ones these are because we need to know which ESCs these plugs are for. So what we're going to do is we're going to label the plug ends so we know exactly, once we've got the top plate, we can just look at the heads and be like, okay, that one's 4, that one's 3, that one's 2, that one's 1. So to do that, we're going to take a hobby knife and we're going to use the knife to carve in the number of the ESC, well, and essentially the motor. Okay, so number 2. Okay, so 1. Okay, so number 3. Now the last step is that we are going to finally solder the motor to the ESC. Something about motors and ESCs is that you have 3 wires on each. The middle one always connects together, and the way we've oriented the motor with the ESC sort of with the sticker on top and the heat sink on top, and the motor in this fashion, if we connect the outside wires together, normally you will get this motor spinning in a clockwise direction. Depends on how the ESC has been programmed. And if you switch the direction, like that, so now they're connected in the opposite direction, then of course these are connected and these two are connected, and of course the middle one is the same for both situations. If you solder them together like this, then the motor will now spin in a counterclockwise direction, again depending on how your ESC has been flashed. So until we do a motor spin up, we won't know the direction. But as a standard in all my builds, I always use this as a standard, where with the heatsink up, if we soldered them together normally, then it will spin clockwise, and if you switch the 2 outer wires, then it's going to spin counterclockwise. So we're going to use that as a standard. Almost in every build on an Epic, it's perfect. Using that format, you'll get clockwise spin and counterclockwise spin. But again, we do have to test that. But use that as a start, and we'll test it, and if we have to, you can either switch the wires, or if you've got programming for the ESC, then you can do that in the software without actually having to resolder. So there we go. So let's get ready to solder. And I'm just working on the last motor here. and I'll give you an overview of everything that went on to attach the motor to the ESC. So we have the zip tie collar, and this is motor number 2, so we're doing a counterclockwise rotation. So we're reversing the hookup. Okay, so like that. We're going to trim the excess wire. Then we take each of the motor wires and we're going to determine the overlap where it's going to be soldered and cut off the extra. Okay. Then we no longer need the zip tie collar, so we remove that. We're going to strip the wires. The first time I showed you using X-Acto knife. This way I'm going to use cutters. Okay, so I'm getting the wire leads ready for solder. I'm going to be applying the flux on the ends. And even on one that already has tin, pre-tin, we want to put flux on there as well. Just cleaning my tip. Okay. Alright, so that's done. So we're going to be soldering the motor wires to the ESC wires. We've got the heat shrink that we're going to slip onto the longer wire side, in this case the ESC, and get them far away from the source of the heat, which is the solder point. Okay. Now, I found an even better way to use this system. I'm going to just use one clip. And you want to clip so that one is stationary. And use your hand to bring it in. And I know it's going to get hot in the wire if you take too much time, but it's also a good precaution, because if you are heating up the wire so much that your wire is that hot, then chances are you will damage some of the electronics. So if your hand is getting really hot, then it's time to stop, cool it down with the fan, and start again. Now, I actually made an error because I'm talking to you. This is the counterclockwise direction, and I'm actually soldering up the wrong pair. So I'm going to hold it again, going to heat it and remove. So this one is not for that wire, it's going to be this one here. Okay, so that one's done. Now when you have a good solder, both tins remelt and they bond together and they harden again, and that's what you want. And you can tell by looking at it, if it gets shiny like that, it's a good thing. I actually moved that during the hardening, so I'm gonna have to re-solder that. Okay. Oh, I did it again. Okay, one sec. And there we go. So those are finished. We're going to slip the heat shrink over those solder points. Okay, and we're going to blast them with the heat gun. Now I'm just warming up the heat gun in advance. And there we go. So once that's done, we're going to route the wires through the channel, making sure it's clearing and it's lying flat. That looks good. Using the hockey tape, we're going to flatten that down and fix it onto the arm. It's a fabric tape that works a lot like the black electrician tape, where it conforms to a surface, but the main difference is that it's easier to take off and it doesn't leave a lot of the residue that's common when you have a black electrician tape on a surface. And we've all seen that sort of slimy, sticky residue, and this has been working out really well. Highly recommended. Alright, so those are the 4 motors soldered to the ESCs. And we are next moving on to attaching the top plate on top of that.